As a software engineer, I find that writing tests and fixing code usually takes much longer than writing the code itself. Our new model, Claude 3.5 Sonnet, can help write tests and fix code autonomously.
Anthropic AI's new model, Claude 3.5 Sonnet, is here to push the boundaries of what AI can do. While ChatGPT-4o is a powerful language model, Claude 3.5 has some remarkable capabilities that surpass GPT-4o. Let's dive into mind-blowing feats Claude 3.5 can accomplish that leave ChatGPT-4o in the dust. Number 1. Solve complex physics questions. Claude 3.5 has shown remarkable capabilities in solving complex problems. One of its remarkable feats is its capability to tackle difficult physics questions that even GPT-4 cannot solve. Physics as a subject involves complex concepts and problems that require a deep understanding of various principles and the ability to apply them effectively. Claude 3.5 excels in this area, demonstrating an ability to not only understand the nuances of these problems, but also to solve them accurately. A key factor behind Claude 3.5's success is its ability to break down complex problems into manageable parts. This approach enables the AI to systematically address each component of a problem, leading to a more thorough and precise solution. Number 2. Genome sequencing transcription. Genome sequencing is a complex process where scientists decode the DNA of an organism, identifying the sequence of its genetic material. This information is crucial for many fields, including medical research, genetics, and biotechnology. However, the data generated from genome sequencing is huge and complex, making it hard to manage and analyze. This is where Claude 3.5 Sonnet comes in. It can take these complex genome sequencing milestones and convert them into JSON, a widely used data format that is easy to read and write for both humans and machines. JSON stands for JavaScript Object Notation, and it's commonly used to transmit data between a server and a web application. By translating genome sequencing data into JSON, Claude 3.5 Sonnet makes it much easier to store, share, and analyze this information. For researchers, this means they can more efficiently work with genome data. They can integrate it into databases, run analyses, and share their findings with colleagues around the world without worrying about the complexity of the raw data. Number 3. Build classic-inspired games. Claude Sonnet 3.5 enables users to create games inspired by classic titles, such as a Mario clone using geometric shapes. It can design a game environment and characters using basic shapes like squares, circles, and triangles. Instead of relying on detailed graphics, it constructs the game's visuals with these simpler forms. This approach simplifies the game design process, making it accessible even to those who don't have advanced graphic design skills. Creating a Mario clone involves several steps, such as designing the levels, characters, and obstacles. Claude 3.5 Sonnet can automate much of this work, generating platforms, enemies, and other game elements. For instance, it can create the main character using a combination of circles for the head and body, rectangles for the limbs, and other shapes for features like the eyes and mouth. Similarly, the AI can design levels by arranging squares and rectangles to form platforms, pipes, and other structures. Number 4. Design pixel graphics. With Claude Sonnet 3.5, users can create stunning pixel graphics, reminiscent of classic video game aesthetics. This advanced tool mimics the look and feel of old-school video game graphics, which were characterized by their simple, blocky designs and limited color palettes. Using Claude Sonnet 3.5, you can design various types of artwork, such as characters, objects, or backgrounds, that resemble what you might have seen in classic video games from the 1980s and 1990s. One specific example is creating an 8-bit style crab using SVG scalable vector graphics. SVG is a format commonly used for creating two-dimensional graphics that can be scaled to different sizes without losing quality. This makes it ideal for digital art and illustrations, including those with a retro 8-bit aesthetic. With Claude Sonnet 3.5, you have tools and features tailored to this style, allowing you to design and customize your 8-bit crab character with ease. Number 5. Computer chips manufacturing. Claude Sonnet 3.5 is capable of generating detailed diagrams that illustrate the complex process of manufacturing computer chips. These diagrams are important for understanding how semiconductors are created step by step, from raw materials to the finished product. Chip fabrication involves a series of complex steps that require precise planning and execution. With Claude Sonnet 3.5, engineers and researchers can visualize these steps clearly and systematically. One of the key benefits of using Claude Sonnet 3.5 is its ability to simplify complex concepts into visual representations that are easy to comprehend. Engineers can use these diagrams to analyze potential issues, optimize production workflows, and troubleshoot problems before they arise. Additionally, Claude Sonnet 3.5 is instrumental in education and training within the semiconductor industry. It provides students and professionals alike with a visual learning tool that enhances understanding of theoretical concepts and practical applications. Number 6, map recommendations. Claude has enhanced capabilities in understanding geographic data and providing contextually relevant recommendations. For instance, when given a map and asked about possible actions or plans for that area, Claude can analyze the map data and suggest activities that are suitable for that particular location. This feature of Claude is particularly useful because it goes beyond just identifying landmarks or geographical features on a map. It actively engages in providing actionable insights based on the spatial information it interprets. This could range from recommending tourist attractions to suggesting outdoor activities, or even pointing out potential areas for development or exploration. This advancement opens up new possibilities for applications in fields such as tourism, urban planning, environmental monitoring, and more, where precise location-based insights can drive informed decision-making. Number 7, real-time editing. With Claude's new artifact feature, users can now enjoy real-time editing capabilities. This feature is powered by the Artifacts tool, which generates code and creates AI-generated content in a separate interface. This enables users to see, edit, and build upon AI-generated content in real time as a big advancement. It means that users can tweak and customize the output to better suit their needs or preferences. This is particularly valuable for developers and creators who work with code and need to refine AI-generated scripts or outputs before integrating them into their projects. Unlike traditional chatbots such as ChatGPT, which provide text-based responses without direct user interaction and editing, Claude's approach integrates directly into the user's workflow. Claude's interface offers a more polished and user-friendly experience compared to conventional chatbots. Number 8, gaming capabilities. Claude 3.5 Sonnet has remarkable gaming capabilities that set it apart in the realm of AI. Unlike GPT-4o, which lacks this specialized focus on gaming, Claude excels by not only executing game-related tasks precisely as instructed, but also going a step further. It integrates a basic yet effective graphical interface with visual aids that enhance user experience and make gameplay more intuitive. This means Claude not only understands the commands given, but also enhances them with visual elements that make the game easier to grasp and enjoy. What makes Claude particularly impressive is its efficiency. While GPT-4o takes longer to process and complete such tasks due to its more generalized approach, Claude demonstrates its coding ability by swiftly delivering enhanced gaming experiences in less than 10 seconds. This speed and precision showcase Claude's advanced capabilities in handling complex gaming scenarios, ensuring that users can interact smoothly with AI-driven games without encountering delays or performance issues. Number 9, web app. One remarkable ability that Claude Sonnet has demonstrated, which GPT-4 or similar models cannot replicate, is the capability to code a fully functional Mancala web application in an astonishingly short span of 25 seconds. This achievement shows not only the speed at which Claude Sonnet can perform complex tasks, but also highlights the practical application of AI in software development. Creating a web application like Mancala involves writing code that manages game rules, user interface elements, and interactive features such as player moves and scoring. Traditionally, Developing such an application would require a lot of time and expertise from human developers to design, write, and debug the necessary code. Claude Sonnet's ability to create code by itself in just 25 seconds demonstrates how AI can make software development faster and more efficient. This quick coding capability has the potential to change how apps are designed and launched, possibly cutting down on the time and money spent during development. Additionally, Claude Sonnet's achievement in quickly creating a Mancala web app shows how AI is advancing in understanding and handling complex tasks in real-world situations. While models like GPT-4 are great at writing and understanding language, they currently can't do things like coding entire applications in real time. This ability sets Claude apart by demonstrating AI's potential to tackle practical challenges beyond just generating text. If you have made it this far, let us know what you think in the comments section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.